Before proceeding with drill sharpening, it is very important that the drill grinder is placed on a secure base and at the right height for both comfort and safety. This base, which is available from J&A Machinery, meets those requirements such as a top working surface that's recessed, 9 square feet of storage space with 4 shelves, and a locking type door handle for secure storage of the champ's operational accessories. The configuration of the base top is designed to permit either the drill sharpener or split point attachment to operate without either attachment interfering with the other. This is the upper drill bed which supports the drill. To the drill bed's front is a locator. It immobilizes the drill for grinding action. To the drill bed's rear is the feed screw assembly which permits drill grinding control. This is a more detailed view of the locator. This is the inclined plane. Smaller drills are locked towards the point, and larger drills towards the open end. The upper bed is now supported by the lower bed, and the feed screw tip of the drill bed butts up against the lower bed's rear edge to control the drill grinding action. Raising the support bed permits the upper bed to grind low cutting edge clearance angles, and lowering the bed produces higher clearance angles accordingly. This is the cutting edge clearance scale. This is the tool post. This is the indicator that lines up with selected lip clearance gradients. This is the anti-shift stop. This is a threaded tension bar, and turning it against the plastic washer increases thread tension to keep vibratory forces from affecting any settings of the anti-shift stop. The anti-shift stop also supports the lower bed, keeping heavy-weighted drills from changing the selected clearance. It's also used for precisely raising and lowering the bed to the desired settings as shown here. We are now making the adjustment for the lip clearance angle. In locking the support bed at the desired clearance setting, note that the left hand's downward pressure against the anti-shift stop is preventing the clockwise tightening torque of the wrench from raising the bed. Thus, the anti-shift stop prevents the desired setting from being compromised. This is the ring scale for drill point angles. Both point and lip clearance angles are explained on the plaque bonded on the side of the motor. Under the platform is the nut that permits the tool post to rotate for drill point angles and lock at the desired setting. The setting is now locked. This is the indexing gauge. These are the baffle lines of the gauge. And parallel alignment of the cutting edge with the red lines establishes the correct relationship of the drill point to the grinding wheel as shown here. This is the platform of the oscillating mechanism. Note how the oscillating mechanism permits the drill to be ground by sweeping back and forth across the wheel's grinding rim. This is the oscillating locking assembly, and turning the lever locks the oscillating system as shown. Now, the oscillating mechanism is firmly locked. This is the second tool post. This is the point splitting attachment secured by the tool post. Both drill sharpening and split pointing attachments can be accommodated simultaneously as shown without either attachment interfering with the other's function. This is the knurled head feed screw. It controls forward excursion of the bed to the wheel as shown. This is the tension nut. Clockwise rotation of the nut increases the feed screw tension to resist vibratory forces from disturbing the feed screw settings. This is the strike plate. and drawing the feed screw back from the strike plate permits the attachment's forward movement towards the grinding wheel's face, as shown here. This is the feed knob. As reviewed from the machine's rear, clockwise rotation transports the attachment towards the wheel's grinding rim, and vice versa with counterclockwise rotation. This is the boss shaft locking screw. It locks feed knob settings. On the front end of the machine, rotating this lever to unscrew the locking mechanism exposes the retaining ring, and removing the ring permits the platform to be withdrawn for disassembly. Then, in loosening these two hex-headed screws, the remaining parts of the oscillating mechanism is drawn to the machine's rear for disassembly. This is just one example of the Champ's sensible engineering. This is the swing stop rod. The higher this rod is raised and locked, the greater the oscillating arc of the attachment to the left of the wheel's outer periphery. It is also used to help support the oscillating locking screw to resist the weight of the bigger drills, in addition to other purposes specified later on. Note that there must be a small piece of steel plate as shown between the swing rod's lower end and the work table. Sharpening the drill. First, check to be sure the grinding wheel is tight, since shipment and climatic changes will cause the wheel to loosen. Then true the wheel by diamond dressing, utilizing both slots on the wheel's cover, as shown here. Make very light adjustments to the feed knob while dressing the wheel. Now use a Norbide dressing stick to stone the wheel. Stoning the wheel will increase the grinding action well over 300%. Note that this is the lip clearance angle scale. This is step number 1. The operator loosens the cutting edge clearance control, permitting the support bed to shift up or down for clearance. The anti-shift stop is now being used to adjust to the desired setting by aligning the setting with the indicator on the tool post. The operator is now locking the setting. Note that the left hand applies downward pressure against the anti-shift stop to prevent the wrench from changing the setting. Step number 2 is selecting the drill point angle. The operator is loosening the drill point angle control, permitting the tool post to pivot to the desired setting. The desired setting is now locked with the wrench. The feed knob is now manipulated to obtain the 1/2 to 3/4 inch clearance between the bed's front end and the wheel, and the knob setting is now locked. Now the swing rod is adjusted to establish adequate clearance gap between the bed's front end and the wheel's periphery, as shown here. Step number 3, indexing the drill. The left thumb torques the drill into the locator, and the right thumb applies steady squeezing pressure against the lower part of the cube, causing the drill's cutting edge to spiral. Avoid drill point and baffle line contact, otherwise the drill will not spiral. So be sure to keep a clearance between the point and the baffle as shown here. Safety precaution demands that the left hand tightens the T-bar screw. The drill is correctly indexed when the cutting edge is spiraled into an alignment with the red lines as shown. Failure to index or incorrect indexing will thoroughly screw up the drill point geometry. The drill bed is now in the lower bed. To the bed's rear, the operator points out the thread tension bar. When the bar is flipped counterclockwise into a downward vertical position, the thread tension is released, permitting the feed screw to operate freely and rapidly with ease. As the bar is flipped clockwise, thread tension is increased to secure the desired feed screw setting. Now the drill bed assembly is pushed up to the wheel. Now if there is feed screw and lower bed contact without point and wheel contact, back out the feed screw counterclockwise while pressing forward on the drill bed until the point contacts the wheel. In case there's point and wheel contact without screw tip and lower bed contact, advance the screw clockwise to establish screw tip and lower bed contact. With drills under 3/16 of an inch, establish screw and lower bed contact, but keep several thousandths of clearance between the wheel and the drill point. Now the swing stop rod is being adjusted to obtain the oscillating arc to the wheel's left as shown. Note that the gap between the drill and the wheel's periphery should be between 1 to 1.5 inches as shown by the wrench. Before grinding the drill, if it is a tapered shank drill that rocks in the bed, place a small piece of angular steel as shown under the drill and up against the cube. The drill is now being replaced in the drill bed. These are the hand positions for drills 1 1/4 inch to 3 inches in diameter. It must be duplicated exactly. Note how the left thumb applies moderate pressure on the left flute to keep it torqued against the locator. Note that the left fingers are wrapped around the outer apex of the lower bed, keeping both beds firmly cupped together. Note that the right hand's fingers likewise wrap around the apex of the lower bed, and the right thumb and index finger is positioned as shown. Now energize the motor and gently slide the drill assembly forward to the wheel, using the right hand to maintain moderate pressure of the drill against the wheel. Note that the drill is being swept back and forth, utilizing the grinding rim's full width. Do not permit the drill to stray off of the wheel whatsoever. Again, be sure to utilize the rim's full width. It is most important, as it assures uniform wear across the rim's entire surface and increases wheel life. The wheel has now sparked out to complete this side of the point. Note that the bed is withdrawn a substantial safe distance back from the wheel to rotate the drill to grind the other side. Take care to twist the drill into the locator as shown. The operator is now placing the bed back into the lower support bed and completing the other side. Spark out has now occurred and the drill is completed. The operator is now attaching the smaller lower bed for sharpening the drills under 3/16 of an inch in diameter. And with the small bed in place, this is the hand positions for the smaller drills as well as short length larger drills. Duplicate these hand positions carefully and exactly. Note that the index finger of the right hand extends to apply mild pressure against the drill stem as shown, and the left thumb, as usual, applies mild pressure on the left flute to keep the drill against the locator. When sharpening drills 3/16 of an inch and under, it is required that the operator locks the oscillating system with the lower support bed in position at the outer periphery of the wheel as shown. Also note that there is an adequate clearance between the bed's front end as shown here. The left thumb now presses the dampening lever firmly to press against the drill while the right thumb tightens the thumb screw. The drill is now indexed in the usual manner. After the drill is indexed, the left hand locks the stop, and the upper drill bed is now in the lower support bed. The operator is now adjusting the feed screw to establish screw tip with the lower bed contact and the small amount of necessary clearance between the point and the grinding wheel. Now carefully note the prescribed hand positions. Note that the left index finger applies pressure against the drill stem while the palm of the left hand applies mild downward pressure to keep the upper bed firmly nestled into the lower bed. Now back off the drill bed at least 2 inches and energize the motor. The motor is now energized. Now the left hand applies downward and forward pressure, gradually sliding the bed towards the wheel. Once the feed screw contacts the lower bed, continue mild downward and forward pressure and back off the feed screw simultaneously with the right hand until the drill is resurfaced and the wheel sparks out. The wheel now is sparked out. At this point, simply twist the drill to the locator of the grinding opposite side and the job is completed. Sharpening spade and track bits. With the spade support bed in place, the anti-shift stop is now being adjusted to obtain the desired cutting edge clearance setting. The left hand is pressing the bed down against the anti-shift stop while the desired setting is being locked. The tool post is now locked at the desired drill point angle setting. The swing stop rod is being adjusted for the adequate clearance arc of the attachment to the left of the wheel's periphery as shown with the wrench. A spade bit is now in the bed. Note that the cutting edge is extended beyond the bed as shown. This extension should be at least 1/4 to 3/8 of an inch beyond the drill bed as shown. With the motor off, now slide the drill bed far as possible towards the wheel. At that point, if the feed screw tip is contacting the lower bed without drill point and wheel contact, back off the feed screw while the left hand applies forward pressure until the point contacts the wheel. However, if there's drill point and wheel contact instead, the feed screw is advanced to contact the lower bed as shown here. Now note carefully the hand positions. At this point, we energize the motor. Note how the fingers of both hands are clamping the beds together. In the meantime, note how the fingers stabilize the spade bit while the thumbs apply pressure through the cube to press the bit up against the grinding wheel. Note the full swinging action across the wheel, utilizing the full rim. Wheel is sparked out. The bit is now being rotated to grind the other side with all settings remaining undisturbed. Note, track bits are sharpened in the same manner, but be sure to use the track bit shim. The tool table. The tool table is in place, attached to the tool post. The swing stop is now being adjusted to obtain the necessary gap to the left of the wheel as shown here. Now the feed knob is adjusted to maintain clearance between the wheel and the tool. For safety reasons, such clearance should not exceed 1/8 of an inch clearance. Now be sure to lock the feed knob setting. Getting acquainted. This is the platform. This is the left horizontal scale. This is the right horizontal scale. This is the fence or the guide. This is the vertical scale. This is the tool post. Under the base platform is the tool post locking control. Calibrating the tool table. The tool table does not normally require calibration. However, where high accuracy is required, it must be calibrated as follows. First, rest the wheel as shown. Then stone the wheel. Then with the fence locked at 90 degrees and the vertical control loosened, square the platform to the wheel's vertical angle using the 90-degree angle gauge block as shown. Be sure to use the anti-shift stop to precisely square the table. Once completed, the operator now tightens the vertical control while the left hand presses the table against the anti-shift stop to keep the setting from being compromised. The tool post is now loosened, and the operator now aligns one surface of the angle gauge block with the fence and rotates the tool table to align the other 90-degree surface of the gauge with the wheel surface as shown. The table is now squared and calibrated both vertically and horizontally. A workpiece is now being ground which will produce a squared surface. Note and especially duplicate the hand positions of the operator. Grinding a thread cutting tool. This is the anti-shift stop and this is the vertical scale. The platform is being tilted up, which will produce the desired side clearance angle of the tool. Note again that the operator is using the anti-shift stop to obtain the new tilted angle. He has now achieved the angle that he's looking for. Now he's applying downward pressure with the left hand up against the shift stop. And now he is tightening the setting. The fence is now being locked at the 30 degrees angle on the horizontal scale, which will produce a 30-degree side angle on the threading tool. To grind the tool, study and carefully note the positions of the hands and the fingers. Please note that either side of the fence can be used depending on which is the most suitable side as the operator is demonstrating at this time. Now energize the motor to grind the tool. Again, carefully note the positions of the fingers while the operator is grinding the tool. One side of the tool is now ground. The operator is locking the fence at 30 degrees on the opposite scale. The setting is now locked. The operator is now completing the second side of the tool. The second side is now completed. The fence is now set at the 90-degree mark to grind the top rake. The table is now being prepared to be set at the 0 degree on the vertical scale. Again, note the anti-shift stop and the tightening procedure. Again, the left hand applies downward pressure against the anti-shift stop, and the wrench tightens the setting without compromising the setting. Be sure that the table is firmly tightened for safety reasons. The oscillating mechanism is now locked to immobilize the system. With the oscillating mechanism in the locked mode, the fence serves as a control to determine the rake's extension. As an example, if the oscillating system is locked with the table towards the inner perimeter of the wheel, the extension of the top rake would be increased and vice versa with the table locked towards the outer periphery, as shown here. Note the hand positions. As a safety precaution, spin the wheel to be sure it's not rubbing due to the required low clearance before energizing the motor. The motor is now energized and the top rake is now being ground. And is now completed. Splitting the point. Using the point splitting bed for indexing, rotate the tool post so the bed and drill clears the wheel as shown. The drill is then spiraled until the cutting edge inclines into a 15 to a 20 degree angle from the vertical. Then the T-bar screw is locked with the left hand. This is the ring scale. And 90 through 85 degrees on the right half of the ring scale produces a notch with neutral through 5 degree positive cutting action. 90 through 85 degrees on the left scale produces a notch with neutral through 5 degrees negative cutting action. The bed is now in position for splitting the point. Note especially the bed's declined angle, which is necessary to expose the flute surface to the wheel's corner. Now study this frontal view. Note that the drill's chisel is to the left of the wheel's corner, which is incorrect. Therefore, the feed knob is manipulated to bring the chisel's lower corner into a position just slightly to the right of the wheel's corner. So, when working the feed knob, periodically resort to the frontal view to inspect the progress. The corrected view is obtained when the chisel's lower corner is just barely out of sight to the right of the wheel's corner, as shown now. With the motor in the off position, adjust the feed screw to establish contact between the screw tip and the strike plate and a small amount of clearance between the drill surface and the wheel's corner, and adjust the swing rod to establish the 1 to 1.5 inch clearance between the drill and wheel, as demonstrated here with the wrench. Now back off the feed screw a quarter turn, and carefully duplicating the hand positions, grind a very slight notch, and examine the notch to be sure the notch's apex is slightly to the left of the chisel's corner. Thereafter, both feed screw and feed knob controls are slightly adjusted accordingly to keep the notch's apex in alignment with the chisel's edge until the notch's apex is several thousandths short of the chisel's midway point, depending on the drill size. Be sure that spark out and feed screw tip and strike plate contact is accomplished before making a new feed screw adjustment. Be especially careful to make very light feed adjustments. The hand positions used in this procedure are for the larger drills to beyond 2.5 inches in diameter. Once one side is completed, all controls remain undisturbed to grind the opposite notch until the feed screw tip reestablishes contact with the strike plate. This is the correct hand positions for splitting the point or dubbing small drills. Note how the right index finger applies pressure on the stem and the left index finger on the left flute torques the drill into the locator. This is a correctly ground modified split point. It has a long notch, which is highly recommended, and being parallel to the drill spiral, chips flow more freely up the notch. And since the notches are in opposite angles from each other, the wed's thickness is not compromised, permitting this drill to withstand much higher thrust pressures. Increasing the downward angle of the drill bed produces longer notches accordingly. Dubbing the drill. Dubbing the drill uses the same drill bed that's used to split the point. Index the drill in the usual manner until the cutting edge spirals into a 90-degree vertical angle, minus or plus 4 degrees, and then use the left hand to lock the backstop. The stop is now locked firmly. Now note the decline angle of the bed. In this position, the feed knob will bring the cutting edge into contact with the rim, and the feed screw controls the extension of the dub surface according towards the chisel. Note especially in this close-up the relationship of the cutting edge to the wheel's arc, as pointed out. The swing stop is now adjusted to permit the drill bed assembly to back off 1 to 1.5 inch clearance from the wheel. Carefully study this dub drill. it shows the correct extension of the dub surface because the surface extends to the central area of the web surface adjacent to and slightly beyond the chisel's corner. Greater or lesser adjustments of the feed knob control expands the dub surface area accordingly. The knurled head feed screw permits greater or lesser extension towards the chisel depending on how much the screw tip is backed off from the strike plate. However, as a precaution to prevent overgrinding, adjust the feed screw so that only the outer 60 or 70% of the cutting edge is exposed to the grinding rim. Then make repeated and light adjustments of both controls until the correct extension and dub surface area is accomplished. So to prevent overgrinding, note that the operator is making a very light feed knob and feed screw adjustment and will resort to frequent inspections during the grinding procedure. The grinding action is now taking place. An additional feed knob adjustment is being made. Now he makes an inspection. Note that the dub surface must be extended further towards the chisel's corner, as shown here. Therefore, a second feed screw setting is now made to extend the dub surface still further towards the chisel's corner. The dub surface has now been extended further towards the chisel's corner, but requires still further extension. Therefore, an additional feed screw adjustment is being made. The dub surface is now adequately extended to a point just slightly beyond or to the right of the chisel's corner. Therefore, at this point, an additional feed knob adjustment is made to expand the dub surface. Now both the dub surface is extended and expanded correctly, and now it is a simple matter of turning the drill around to the opposite side to grind the opposite face. Please note that the settings remain undisturbed to grind this side. The operator is applying very gentle pressure to grind the opposite face. Spark out is now being achieved. Spark out is now achieved, and the job is completed since the feed screw has established contact with the strike plate, as shown by the operator. Grinding the top rake on spade and track bits. To grind the top rake, first round off the wheel's corner to an approximate 1/8 of an inch radius with a Norbide dressing stick, as shown here by the operator. Note that the cutting edge projects 1/2 inch to 3/4 of an inch beyond the bed's vertical wall. For track bits, use the track bit shim between the bed's wall and the bit. This control on the skew post permits the desired skewed angles. The vertical control and feed screw is used to obtain the bed's angles, as shown here. After all controls are manipulated, as shown by the operator, a relationship of the cutting edge and wheel's arc is accomplished, as shown here by the pointer. Now the swing rod is adjusted to permit the bit to back off from the wheel. Now energize the motor. And carefully duplicating the hand positions, as shown here, Note that the feed knob controls the top rake's depth, and the narrow feed screw controls the rearward extension of the rake. Adjust these controls accordingly to make a very light and frequent grinding passes until the desired top rake and depth extension is accomplished. Once the desired amount of top rake is accomplished on one side, the spade bit is then rotated to grind the other side. However, all controls remain undisturbed to grind the second side. The operator merely continues to apply very light pressure against the grinding wheel until the second side is completed. And now the job is completed. Helpful hints. If a drill is sharpened with a cutting edge clearance angle of AC or lower, manually grind a small secondary step using the wheel's face. If the secondary point angle geometry is desired, simply rotate the tool post to align the number 90 mark with the initial SPA and lock the selected setting. Then grind the desired length of secondary cutting lips. Rotate without disturbing the settings and complete the second side. If a 4-faceted self-centering point is desired, grind the primary cutting edge facets as usual, and then increase the cutting edge clearance angle by at least 3 gradient marks. To grind the secondary facet, make frequent minor adjustments of the feed screw with spark outs until the secondary facet is extended to the midway point of the chisel's long axis. Then, with the feed screw remaining undisturbed, rotate the drill to grind the opposite side until the wheel sparks out. When grinding broken drills, grind a little bit more than halfway through the drill's diameter, then index the newly constituted cutting edge, grind the new edge until it is fully resurfaced, and grind the other side to completion. Then, as a precaution, re-index a second time and regrind if necessary. An additional corrective grinding operation is required occasionally to restore correct drill point geometry. For badly worn drills, overground drills, changing from one point angle to another, or when converting from conventional points to the flat grind, index and grind as usual, and then re-index and regrind. Again, it is best to re-index a third time to be sure the correct geometry has been established. If a drill doesn't function, it's due to insufficient lip clearance, resulting from improper indexing, insufficient secondary facet size on the drill sharpened with a low lip clearance, or excessive grinding. Correct grinding begins in the area of the heels, and as soon as it moves forward to completely resurface the cutting edge, grinding must cease immediately. Further grinding reduces lip clearance accordingly, and if excessive grinding occurs, the drill must be re-indexed and reground. Inaccuracy results from failure to grind until the screw tip engages the lower bed. Inadequate feed screw thread tension, drill not fully engaged in the locator, unequal or distorted lands, bent drills, flute debris, failure to sweep both drill faces equally across the grinding rim's full width, inadequate tightening of the lip relief, drill point angle or drill stop lock controls, or failure to raise the shift stop into contact with the lower bed. Most important, with drills, especially large ones, increased heat buildup and expansion in grinding the second face results in additional metal removal and inaccuracy. So a coolant is a must. Short-bodied tapered shank drills tend to rock in the drill bed. This is prevented with short pieces of extruded aluminum angle or steel under the shank's rear edge against the cube and taped to the drill bed. For offset point centers to prevent drill binding in deep soft metals, complete both drill faces and back off the feed screw to grind a slight additional amount from the second face. Do not remove the plastic washer on the feed screw mechanism. To retain its frictional properties, avoid lubricants and keep it clean with soap and water. After wheel dressing, always stone the wheel lightly with the dressing stick. It opens the wheel and increases grinding action at least 200 to 300%. Diamond dressing is best for truing the wheel, but also dulls the wheel and drastically reduces grinding action. Due to the machine's unlimited drill diameter range and ability to grind a wide range of tools and other metals, it is recommended to maintain fine and coarse grit wheels on hand for maximum customer satisfaction. For best results, use interchangeable diamond wheels for drills number 60 through 1/8 of an inch diameter, number 60 grit for 1/8 through 3/8, 46 grit for 3/8 through 3/4, and 36 grit for drills above 3/4 inch diameter. For replacement wheels or operational assistance, be free to contact us at the address as listed. J&A Machinery Company, 3136 Federal Avenue, El Paso, Texas, 79930.